Good morning, everyone. Myself, I am G. Charan from Tripoli branch. Today's my tech talk topic on DC machines and transformers are supercapacitors outperform conventional batteries, energy and security. A supercapacitor, SC also called an ultracapacitor, is a high capacity capacitor with a capacitance value much higher than other capacitors but with lower voltage limit that bridges the gap between electrolytic capacitor and rechargeable batteries. It typically stores 10 to 100 times more energy per unit volume or mass than electrolytic capacitors. Can accept and deliver charge much faster than batteries and tolerates many more charges and discharge cycles than rechargeable batteries. Supercapacitors are used in applications requiring many rapid charge or discharge cycles rather than long term compact energy storage in automobiles, buses, trains, cranes, and evaluators, etc., where they are used for regenerative braking, short term energy storage, or burst mode power delivery. Smaller units are used as power backup for static random access memory. SRAM full form is static random access memory. Unlike ordinary capacitors, supercapacitors do not use the conventional solid dielectric. Static random access memories, ordinary capacitors or supercapacitors do not use the conventional solid dielectric. They use electrostatic double layer capacitance and electrochemical pseudo capacitance, both of which contribute to the total capacitance of the capacitor with a few differences. Electrostatic double layer capacitors, EDLC's full form is electrostatic double layer capacitors, use carbon electrodes or derivatives with much higher electrostatic double layer capacitance than electrochemical pseudocapacitance, achieving separations of charge in Helmholtz double layer at the interface between the surface of a conductive electrode and an electrolyte. The separations of charges of the order of a few angstroms 0.3 to 0.8 nanometer, much smaller than in a conventional capacitor. Electrochemical pseudocapacitors use metal oxide or conducting polymer electrodes with a high amount of electrochemicals. Electrochemical pseudocapacitors are used metal oxide or conducting polymer electrodes with a high amount of electrochemical pseudocapacitance additional to the double layer capacitance. Additional to the double layer capacitance. Pseudocapacitance is achieved by Faraday electrons charge transfer with redox reactions, intercalation or electron sorption. Hybrid capacitance such as the lithium ion capacitor use electrodes with differing characteristics, one exhibiting mostly electrostatic capacitance and the other mostly electrochemical capacitance. The electrolyte forms an ionic conductive connections between the two electrodes which distinguishes them from conventional electrolytic capacitors where a dielectric layer always exists, and the so-called electrolyte MnO2 or conducting polymer is in fact part of the second electrode, the cathode, or correctly the positive electron. Supercapacitors are polarized by design with asymmetric electrodes or for symmetric electrodes by a potential applied during manufacturing. Security for all present day consumer electronic products, especially those operating on DC voltage or power. Supercapacitors or supercapacitor modules may replace these product batteries in the near future, eliminating batteries and all of the shortcomings associated with their technology because these CE products requires a constant DC voltage for operation. A state of the art DC converts module operating only on supercapacitor without a battery is envisaged. A proposed DC convert module would deliver the required constant voltage to the CE device from the supercapacitor corresponding to the dropping or decaying voltage of the supercapacitors of the supercapacitor module. The future power sources system example laptops, mobile phones, etc. have become a part of our day-to-day life with the modern era advancements in technology. CE electronic systems and handheld devices including camcorders, tablets, and mobile phones, etc., uses batteries for energy storage. With the enhancement in the specification of this device, high capacity batteries, example lithium ion, are required. These batteries take longer to charge and discharge comparatively faster to meet the power requirement for high specification communication electron device. A supercapacitor SC full form is supercapacitor, sometimes ultra capacitor, formerly electric double layer capacitor. EDLC full form is electric double layer capacitor. Is a high capacitor electrochemical capacitor with capacitance values much higher than other capacitance but lower voltage limits that bridge the gap between electrolyte capacitor and rechargeable batteries. They typically store 10 to 100 times more energy per unit volume or mass than electrolytic capacitors can accept and deliver charge much faster than batteries and tolerate many more charge and discharge cycles than rechargeable batteries. They are, however, 10 times larger than conventional batteries for a given charge. Supercapacitors does not Supercapacitor does not have a separate identifiable dielectric. The electrodes are formed by high porosity active carbon having very large surface area in a given volume. The electrolyte fills all the pores fully and creates a natural extremely thin layer of oxide at the contact surface with this electrode. This sub-nanometer thick layer, a Helmholtz effect, acts as a dielectric. A double layer formed at this interference acts as dielectric to give very high capacitance value. Two such layers at the two electrode surface make for two capacitors in series. The two carbon electrode surfaces are separated by a membrane. Metal electrodes on which the carbon is deposited acts as current collectors connected to external terminations. Electrochemical pseudocapacitors use metal oxide or conducting polymer Electrodes with a high amount of electrochemical pseudocapacitance additional to the double layer capacitance. Pseudocapacitance is achieved by Faraday electron charge transfer with redox reaction intercalation of electroporation. Hybrid capacitors such as the lithium ion capacitors use electrodes with differing characteristics, one exhibiting mostly electrostatic capacitance and the other mostly electrochemical capacitance. Mostly electrochemical capacitance. Thank you.